Okay, so first we're going to run the System Builder software and open up a blank model called vehicle.sim. And then what we're going to do is run one of these file commands over here to make what I'm calling the V1 model. And we can edit the file command just to see what's going on. So the steps in this file command are to add from the library the subsystem called UV1, then the V1 subsystem, and then the DV1 subsystem, and then to generate the code associated with those subsystems. The UV1 subsystem is just designated as upstream of V1, so it just feeds some information to the V1 subsystem, and the DV1 subsystem is downstream of V1, so it just receives some information from V1. This is an extremely simple model, as we'll see in a moment. So if I run that file command, I see the model built on the desktop here. There's the UV1 model, so all it does is it takes a force, it outputs a force, which is given in the parameters here. The V1 model then consumes that force as an input and then divides it by the mass to compute an acceleration. So it's just Newton's law. We're just finding the acceleration from the Newton's F equals ma equation. Almost the simplest model you can think of. And then the acceleration is going into this DV1 model and is being output by that DV1 model. So that's all this does. So what we'd like to do now is invoke some replacement rules to change the V1 model into a higher fidelity model called V2. And we're going to do that. So let me show you what I'm talking about here. I have a V2 model in the model library, and what that contains is are two F parameters, two force parameters. So there's an F1, instead of just an F, there's an F1 and an F2. There's two forces acting on the body. And there's two at two distances from its centroid, D1 and D2, and a mass of the body. And so this basically does the same thing, but it does it with more inputs. It computes the acceleration and it computes the torque. And you can see the calculation there. And if we want to replace V1 with V2, we could invoke these replacement rules, which, when they're enforced, to make the V2 model look like the V1 model to the rest of the subsystems in my system model. So in this case, we want the F1 of the V2 model to be equal to F. Okay, F2 will just be equal to 0, D1 and D2 will be equal to 0, and we have a name change. Our M variable from this new model is equal to the mass coming from the V1 model, and the AV1 that's being output by the V1 model is equal to the A variable, that's the acceleration of course, in V2. So a lot of this is just mapping variable names, so the new system model knows what to do with V2. Okay, so if we do those replacement rules, we just have to say which model we're trying to replace. We're trying to replace V1 with V2, and we want it to be called V2 in the new subsystem. We say OK, and there's our V2 model, just the same as we just saw. And it's taking its inputs now from the input adapter, which gets built. So this input and output adapter get built based on the replacement rules. So basically the input adapter is taking the F output from UV1 and turning it into an F1 that's then being consumed by V2. The output adapter is taking the A, the acceleration, from V2, and it's turning it into AV1 for consumption by DV1. So to UV1 and DV1, it looks like, if we draw a circle around these three subsystems that have been added to the model, it just looks like the V1 model because we've created all the mapping. So the idea of replacement rules is just to give you a kind of a head start on fidelity replacement. So that's what happens. We have a perfectly good model here, of course, but in the next video what we're going to see is how we can, further transform this model into the fully fledged V2 model, the higher fidelity model that we want.